I have to define the step 1. So I have to write the hypothesis, right? So hypothesis, the population mean is equals to 0. That means the drug has no effect, right? So no effect means 0 effect. So if somebody comes with blood pressure and he's taking the tablets and the tablet is not making any effect, so that means 0 increment, right? So that's why the hypothesis mu is equals to 0. So what is the opposite or the negation of this? So no effect, there is an effect, right? So when do you say there is an effect? If there is a positive increment, you say there is an effect, and if there is a negative increment, also you say there is an effect. Okay, so that is why you need to put not equal to 0. So this we call this test as two-tailed test. So whenever the alternative hypothesis you are getting a not equal sign, then the test is known as two-tailed test, because the rejection region will come in both the tails. Okay, that's why it is called two-tailed test. So step 2, you need to write the critical region. So critical region or rejection region. So rejection. So when under what circumstances you are going to reject the null hypothesis? Okay. So that's rejection region. Rejection region. Okay. So under which circumstances you are going to reject the hypothesis? So now you can draw this graph. This is a T graph, right? And since it is a two-tailed test, the rejection will come on both the sides. So since it is a 5% significant level, so the alpha is the type 1 error, right? So the type 1 error. So this alpha will be, since the rejection region is on both the tail, so the alpha has to be divided by 2. So you have T alpha by 2. So 0.05 divided by 2, you will get T 0.025, and the degrees of freedom. So you have here 11 samples. So 11 minus 1, so 10 you will get here. Similarly, this side will be negative, right? So negative T 0.025, comma 10. Okay, and this point here, if you look at the okay, I will explain that later. Okay, so now, so what is the decision here? Reject H0 if T calculated value is greater than T 0.025, comma 10. Okay, so accept H0 if T calculated value is less than T 0.025, comma 10. Okay, so or reject H0 if negative T is less than negative here this side. So if your calculated value falls here, you reject the hypothesis, and also if it falls here, you will reject the hypothesis. Okay, so that's the statement I wrote here. So reject H0 if T calculated value falls here. So that is calculated T 0.025, comma 10. If this side, it will be negative. So reject H0 if negative T cal less than negative T 0.025, comma 10. Okay. Hope this is clear. So you need to calculate the test statistic. As I said earlier, the test statistic is a formula that you need to calculate. So T is equals to x bar minus mu divided by S divided by square root of n. This is the formula. Okay. So this is equals to what is my x bar? So my x bar is 2.45 minus my mu is 0 from the hypothesis divided by my standard deviation is 3.45 divided by my sample size is square root of 11. Okay, so when you simplify this, you will get 2.36. Okay, so now you have to step 4. So you have to make the decision now. So what is the decision? So this is the graph, right? T graph. So if you look at the T table here, so the degrees of freedom is here, right? This is degrees of freedom. So I'm looking at 10. So 10 go across, and my T is like 0.025. So here 0.025 and 10. So that is 2.228. So this point here is 2.228, and this point here negative 2.228. And now you see the 2.36. This is my calculated value. From the sample, I worked out this 2.36. So definitely 2.36 falls here, right? So this is where 2.36 falls here. So what is this? This is reject H0. So whenever your calculated value falls either here or here, you reject the hypothesis. Now 2.36 falls here. Okay, therefore we are going to reject the hypothesis. In other words, there is no sufficient evidence to accept your null hypothesis. So interpretation, since T calculated value, so which is equals to 2.36 is greater than T tabulated value, which is equals to 2.228, come on, we reject the hypothesis H0. Therefore the drug administered to the patients is effective. So the drug is effective.